Church-Turing Thesis. You know, these two guys are two of the interesting guys in the history of computing. This guy has been the PhD supervisor of the Turing himself, and there is one interesting point in here. He himself has been a very interesting guy, lots of theses, etc. As you can see in the lecture of week 8. He has introduced the lambda calculus theory, and also the Turing has been his PhD student. He also has introduced a lot of interesting stuff. But Turing, like I said, that's the thesis of Turing. They say any real-world computation can be translated into an equivalent computation involving a Turing machine. That's really interesting thesis and hypothesis, I would say. So there are some discussion in here. I don't want to go through that. Last week we discussed that. Well, I want to talk about the Turing himself. Turing has been a really interesting guy. He has joined he has actually worked on a specific machine which is called Bombi. And the mission of that machine was to break the cryptography, encrypt actually, I would say decrypt the codes in the German U-boats in Second World War. And it is claimed that the machine he invented helped the war be finished 2 years before the time it was going to be finished, and it saved 2 million people's lives. So see how science can help the people and the world. So then afterward, he had some problem. He was just arrested because of the gross indecency. And they gave him 2 choices, sadly, the chemical treatment or jail. He accepted the chemical treatment, and the chemical treatment applied lots of problems in their health, unfortunately. And then finally he died in 1954, age of 42. That's really, really poor and sad story, isn't it? That guy, only by the age of 42, has delivered the Turing machine and lots of the interesting scientific stuff. Imagine if he was alive by, I don't know, 80, 100 years or something like that. And then because of that, they started some petition to say appalling or saying apology because of that very, sad decision of the court and stuff, etc. Anyway, that's the whole story of the world. Sometimes the stories like that. Anyway. And then one interesting problem that was started at that time was the halting problem. That's the thing we didn't have time to discuss last week, and we won't go through that. So for the halting problem, that's the very interesting question. Does a computer program exist that can take in the code of any computer program and decide if that program will ever stop running? So that's the story. So I have a program, you can write a program or code that can halt at some stage, or the program that cannot halt. Look at this code. So do you think this code is halted? Do you think this code is halted, or it is continue forever? What do you think? It won't halt, as you can see, because while true, all the time it is true, and it prints all the time, hello world, hello world. So we can have some programs which never halts, and also we can have programs which halt at some stage. For example, this one, as you can see, it halts exactly just after one execution. So as you can see, we can have some programs, some codes, which they never halt, and we can have some which halt. So the halt question, the halting problem in here is, if I have a program, if I have a code, and I have another code which I will give the first code to it, and it can decide if the program will stop running or halt or not. So the above question is halting problem. The decision problem H, the halting problem, is the set of all A. I mean, all the program that halts inputs A. So that's a little bit complicated, the sentence in here. Can we write a computer program that takes in any other computer program as input and correctly tell us if the program halts or not? So what do you think? Is it possible to have a program which receives another program and say if that program will halt at some stage or not? Do you think what's the answer? Is there any program possible? Is it possible to have a program like that which can decide if a program can halt or not? What do you think? Do you think, is it possible to judge, let's put it another way, is it possible to judge if a program will halt or not? Any answer? Any reply? Any idea? Any thoughts? Do you think, is it possible to judge on a code or something like that? Let's jump to the course and see what happens. So the answer is no. Turing proved that it is no, impossible. It is impossible to have a computer code to say that if it is, if the second code is can halt or cannot halt. It will halt or never will halt. Okay, so that's the idea they use to prove if it halts or if it doesn't halt. So if you have a Turing machine A, it says that's the way it works. It says if P halts, if the answer is yes, okay, then the machine halts. If the program halts, then the Turing machine says, okay, that program halts, that machine halts. And if the program by itself doesn't halt, and then that means the machine does not halt. Okay? And imagine we have another Turing machine which works exactly in the opposite. That means if the program halts, yes, then the Turing machine won't halt. And then if the program halts, no, and then machine halts. So it works exactly the other way around. So that's the reason why we have these two pictures for this machine. That's a good machine which halts, which works exactly as the program does. And we have another machine which does exactly the opposite of what the program does. So imagine we combine these two machines. Imagine we will feed machine B into machine A. Imagine what will happen. What will happen is we have a program. We will feed it to the machine B. Machine B says if it halts, yes. So machine says no, I won't halt. Doesn't halt, the Turing machine doesn't halt. And if the Turing machine doesn't halt, this guy says the answer is no, so you should follow this path. So it would never halt. And then let's follow this path. If it says if the program halts, no, so machine says I will halt then. And then if the machine halts, according to first one, it says yes, it will halt. Okay, so since we can readily come up with the Turing machine B that causes Turing machine A to return the incorrect answer, this, that's much easier. Since we can readily come up with the Turing machine B that causes Turing machine A to return to the incorrect answer, this shows by contradiction that it is not possible to write a program that can take any other program as input and correctly return whether or input halts or not. So as you can see, the program halts, and that's the other ways around. So that's the whole story. Like I said, that's the halting problem. And the halting problem is the problem of if there is a program and if it is possible to decide on a program if it halts or never halts. And people have shown that it is not possible, it is impossible, it is undecidable. And that was the proof how it is undecidable. You can look at the slide later yourself and the video yourself. And that's the description I have talked about.